This project is made possible in large part through the support of my viewers on Patreon and more recently through channel memberships here on YouTube. Without their generous support, I don't think I'd be going ahead with this project. We left off last time with me building the lift and tilt, and here you can see exactly how that works. The lift bar slides across and it changes the depth of cut for the blade. Since that time though, I've changed my mind and I've decided that I'm not going to use the inclined plane mechanism, but rather I'm going to use a small gear motor to power the lift up and down. And to that end, I made a mock-up with a motor that I already had and temporarily attached it to the lift just to see how well it would work. And as you can see, it's working well, so I decided to go ahead and make the changes to install the lift motor permanently, and that's what I'll be doing in this video. And the first thing that I did to get started on that was I took out the lift bar and the lower inclined plane, since those won't be needed anymore. So building the mock-up gave me some definite ideas about how I want to do this. I know that I want to use a regular 1/2-inch threaded rod as the lead screw to lift and lower the carriage. And the tricky part is coupling that to the motor shaft. And I did that in the mock-up with a wooden block, but that's kind of cumbersome and bulky. And I think a better way is to actually drill a 1/4-inch hole in the end of the threaded rod. To accomplish that here in my woodworking shop where I don't have any specialized metalworking tools, I'm using my wood lathe and I've got the threaded rod mounted in the chuck. And what I'm going to do first is I'm going to taper the end slightly using the grinder. And what this will do is it'll allow me to push the threaded rod all the way in so that it sets in the Morse taper, and that'll stabilize the back end of the threaded rod. And then I can tighten the chuck jaws around it to keep it rock solid. And now I've taken the chuck off my drill press and mounted it in the tailstock, and I'm using a small step drill as a centering bit. And then after that I can switch to a 1/4-inch twist drill and drill in about 3/4 of an inch. Okay, I'm reasonably sure that the hole that I drilled here is centered. And now to connect the motor shaft to the threaded rod, I'm just going to use a pin. And the first thing that I did was I filed a flat spot on the threaded rod. And this is a very small drill bit, 5/64, so I have to be careful while I'm drilling through this that it doesn't break. And now that the hole's drilled through the threaded rod, I'm going to slip the motor shaft in with the flat side up and drill through the hole again just to mark that shaft. Then I can take it out and clamp it in the vise and finish drilling the hole through. And I'm just using a nail for the pin. And this is actually smaller in diameter than the hole that I drilled. And that was intentional. I actually want some flexibility here between the motor and the lead screw. All right, that's the lead screw. And I'm not done with this yet. I've got a couple other things I need to do with it. But before I do that, I want to move on to making the plate that attaches directly to the lift. And this is going to have a 1/2-inch nut welded on, so I need to drill a hole through and then bring that out to my shed where I can weld it on. Now back in the shop, I need to modify the rear cover of the lift by cutting a big hole in it. And I could take the whole thing apart again and cut this out with a jigsaw, but instead I'm going to do it with a router by setting up a template here. And I'm just using strips of hardwood that I'm going to pin nail to the rear cover and then run the router around that to cut out the hole. Okay, that looks good. I also need to cut out a smaller slot for the lead screw. And I'm going to do that exactly the same way by nailing on these strips temporarily and routing it out. Now I need to get back to a little bit more woodworking. I need to build another structure that the lift and tilt fits into, And normally I wouldn't have to do this part yet, but the lift motor actually mounts on part of this. And there are basically 4 parts that I need to cut out here. The first 2 are 3/4 of an inch, and the other 2 are 1/2 inch. I'm using pins to line up the parts exactly while I drill pilot holes and drive in the screws. And with both sides put on, I can slip it onto the lift and tilt. And after I have it clamped exactly where it's supposed to go, I'll drive 4 screws on each side. Now that I have that bracket put in place, I can go back to working on the motor, and I need a block that holds it in place, and I need a hole in here that's just a little bit less than 1.5. And I really don't have a bit that size, so I'm gonna go to the next size down, which is 1 3/8, and then I'll bring it over to the spindle sander and sand it until it's a perfect fit. Okay, with that little bit of business taken care of, I can go back to the lead screw. And what I need to do next is I need to add nuts to this. That's going to keep it in place as it turns, one on top, one on bottom. And normally you would use 2 and then jam them together, and that would keep them from moving. But that's going to take up too much space here. So what I'm going to do instead is I'm going to pin these as well by drilling a hole through and using a nail to lock them in place. And I've got it mounted in a 3/4 inch block, and I need to leave just enough space here so that the lead screw turns freely after those nuts are pinned in place. With the lead screw in place, I can add the motor, and because I cut that slit in the mounting block, it'll clamp down on the motor when I drive in the screws. And with that done, I can test it out and see how it works. And since I still need to mount the drive motor on this lift as well, I want to see how much power it has, so I'm actually trying to stop it here with my hand. And I'm happily surprised because it takes a lot of force just to slow it down. With all the lift stuff sorted out and ready to go, I can move on to mounting the drive motor. And the motor I'm using is actually a pump motor from an old hot tub. And I did some work with this about 5 years ago, where I added a bearing at the front here and also put this plywood plate on. And there's a link in the description to the video where I did that work, if you're interested in watching that. And this motor gets mounted directly to the lift carriage. And to do that, I need to build a couple of brackets from plywood and fasten those to the plywood mounting plate that's already on the motor. I'm using a link belt for this rather than a traditional rubber belt. I find they're smoother and the power transmission seems to be better. Not to mention that I can custom make it to the size that I actually need here. So after figuring out how long that needs to be and putting that in place, I'll line up those brackets and screw them right onto the rear cover of the lift carriage.